Welcome to the UNV certification program. The topic of this video is LCD fundamentals. This course can enable you to get to know LCD structure, LCD definition and working principle, and some LCD general parameters. Now let's get started. First of all, let's see LCD structure. An LCD monitor is generally composed of the following 6 parts: front cabinet, LCD module, diffuser, backlight, control board, rear cabinet. The front cabinet is mainly to protect against dust and scratches. As the most important part of the LCD monitor, the LCD module processes the light of the backlight system to display the image. The diffuser is a small layer of plastic that is designed to diffuse and distribute light evenly across an LCD module. In addition, the backlight system is used as a light source. And the control board, the heart of the monitor, is to control the crystals to display images and text. Finally, the rear cabinet. It has a design with features like efficient radiator holes and easy-to-use interfaces. When talking about the working principle, we will see its functions in detail. Secondly, we take a look at its definition and working principle. Before introducing the working principle, let's take a look at a very interesting component, the polarizer, which is an optical filter that allows light waves of a specific polarization to pass through while blocking light waves of other polarizations. In fact, natural light is multi-directional. For example, we can see a parallel polarizer. Only the light parallel to the transmission direction of the polarizer can pass it, while the light in the other directions will be blocked. Now let's see how the polarizer works in detail in the whole process. LCD stands for liquid crystal display. Liquid crystal is a substance that has both the fluidity of the liquid and the periodic arrangement property of crystals. Under the action of the electric field, the arrangement of liquid crystal molecules will be changed, thus affecting its optical properties. This phenomenon is called the electro-optical effect. Liquid crystal displays are made based on the electro-optical effect. As for the working principle, liquid crystal is sandwiched between 2 sheets of glass, as shown on the left in the picture. When there is no electricity, the liquid crystal molecules are arranged parallel to the polarizer. When the light enters the first vertical polarizer, only the light in the vertical direction can pass it. Then the light passes through the whole liquid crystal layer that is displayed parallel. Its direction turns to parallel as well. Then the light passes through the parallel polarizer. The screen turns bright. When the electricity is on, the arrangement of the liquid crystal molecules will be changed to a vertical direction. Then the light goes in the vertical direction too, and gets blocked by the parallel polarizer. So the screen displays dark. Liquid crystal molecules act like a small light valve. By changing the voltage across the liquid crystal layer, the light transmittance can be controlled. When placed with a color filter, the screen will display different colors. Therefore, the LCD monitor is a kind of monitor that uses liquid crystal to control the light transmission technology to present different images. By this principle, you will know the LCD screen works on the principle of blocking light rather than emitting light. An LCD requires a backlight system. Now let's get more detailed info about the backlight system. There are 2 types of backlight systems. The first one is the direct backlight system, which is placed directly behind the LCD panel. It has high brightness but is a little bit thick. The other is the edge backlight system. In this backlight system, the backlight will be placed in the edge corner and requires a light guide to transmit the light. Compared to the direct backlight system, it's thinner and has a lower brightness. In front of the glass, there is a color filter. With the help of the color filter, the light will be transformed into different colors. Thirdly, we are going to talk about some common LCD parameters. First, we will look at resolution. It's a very common parameter, no matter for cameras or for LCDs. It means the number of distinct pixels in each dimension that can be displayed. The screen resolution, which is measured by horizontal and vertical pixels, determines how much information can be displayed on the screen. The general resolution is defined by horizontal lines, such as 720p and 1080p. Generally, the higher the resolution of an image, the more pixels it contains and the clearer the image will be. The next parameter is refresh rate. It is the number of times that an electron beam scans repeatedly an image on the screen, and the number of times per second your monitor can redraw the screen. The higher the refresh rate, the more stable the displayed image is. For example, 60 Hz means the screen is refreshed 60 times per second. Nowadays, high refresh rate screens are very popular. Even in the mobile phone industry, 120 Hz has been applied. FPS frame per second is how many frames your device is producing or drawing, while the refresh rate is how many times the monitor is refreshing the image on the screen. Let's put these two parameters in a camera to make an example. The frame per second in a camera means the number of images the camera can capture per second, while the refresh rate indicates the number of images the camera can display on the screen per second. The former is like input and the latter output. Does that mean the frame rate of an IPC is limited by the screen's refresh rate? Not always. The refresh rate of the screen does not affect the frame rate of the IPC. However, if the IPC's FPS is higher than the screen's refresh rate, the screen will not be able to display all the frames the IPC is producing. It is important for both of them to be in sync in order to avoid visual defects such as screen tearing. Response time is how quickly the display can have an LCD pixel change from white to black and to white again. A lower response time typically means less ghosting of the image and better picture quality. Brightness is a very important parameter for LCD. When too bright, the display will make people feel uncomfortable. It is easy to cause visual fatigue on one hand and reduce the contrast between black and white on the other hand, affecting the performance of the color scale and grayscale. While low brightness may cause problems such as screen flickering and eye damage. Therefore, a good display must have a uniform and moderate brightness. Contrast is the ratio of the brightness of the same point on the screen when it is the brightest and the darkest. The higher the contrast, the more details the display will show. However, it takes high R&D and hardware costs to improve the contrast ratio, so the term dynamic contrast ratio began to prevail in the market. The principle of dynamic contrast ratio is to control the backlight current. That is, increase the backlight current to get a bright image, and reduce the backlight current to get a low brightness image. Thus we get a greater contrast ratio value. Generally speaking, the dynamic contrast ratio has a low reference value. Therefore, when we look at the contrast ratio parameter, it's advisable to take the static contrast ratio value as the key point, for it is a more reliable indicator of the monitor's performance compared to the dynamic contrast ratio. Now let's move on to viewing angle. It refers to the angle at which users can clearly observe all content on the screen from a different direction. Compared to other types of front panels, IPS panels have advantages in terms of viewing angle. Finally, here is the color gamut. Color gamut describes a specific, measurable, and fixed range of possible colors and luminance values. There are different color standards, for example, sRGB, Adobe RGB, and NTSC. For a good monitor, the color performance should be at least 72% NTSC or 100% sRGB, and at least 90% NTSC for an excellent monitor. By now, we have introduced some common parameters of LCD, which enable you to judge the quality of the product. In fact, there are also 3 different kinds of panels in the market, and each has a different working principles. So now let's have a look at them. Actually, what behind the 3 panels' working principles are these 3 different technologies, IPS, TN, VA. We will introduce them one by one. Firstly, TN screen is the soft screen, which has the most mature production technology and the lowest cost. TN screen responds quickly, for the fastest response time can be 1 millisecond, with no residual images. Therefore, TN panel is usually used as a professional gaming screen. Secondly, IPS means in-plane switching like all LCD screens, using voltage to control the alignment of liquid crystals, but unlike the TN, IPS LCD uses a different crystal orientation, where the crystals are parallel to the glass substrates, hence the term in-plane. The panel of IPS screen is harder. When you touch the screen lightly, the screen will not be distorted. For the color display and viewing angle, IPS panel is better than TN panel. As for color rendering range and accuracy, it also has impressive performance. What's more, a wide viewing angle is the native advantage of IPS panel, since it will not produce the color shift wherever you are looking from. Generally speaking, the IPS panel is mostly used for image processing. Thirdly, VA stands for vertical alignment. As the name suggests, this technology uses vertically aligned liquid crystals that tilt when a voltage is applied to let light pass through. This is the key difference between IPS and VA. With VA, the crystals are perpendicular to the substrates, while with IPS they are parallel. VA screen is also a soft screen. It is characterized by high contrast. For example, black and white in the display are purer, and there is no light leakage problem. And the main shortcoming of the VA screen is the longer response time than others. By performance, you can see that different technologies have different advantages. In terms of color, IPS is better. Regarding the response time, TN is better. On the view angle side, IPS is better. When it comes to the contrast, VA is better. In summary, in this course, we've talked about the LCD structure, have a good command of LCD definition, and understand the working principle and some common LCD parameters. That's all for LCD basic knowledge. Thanks for watching. See you next time.